Hey there, welcome back to the LLM implementation channel. Today, I'm going to continue doing some fine-tuning for large language model things, especially fine-tuning the Llama models. As you guys have probably heard, the latest breaking news in the large language model space is that Llama 4 has been released. A few things we can see here. It has 3 models with different parameter sizes. The biggest one has 288 billion active parameters, 16 experts, and 2 trillion total parameters. The middle-sized one, the Maverick, has 17 billion active parameters, 128 experts, and 400 billion total parameters. The smallest one also has 17 billion active parameters, 16 experts, and 109 billion total parameters. The nice part is that it can handle 10 million context length for inference. So that's impressive. But what I'm interested in is to go to the chatbot arena that the model Llama 4 Maverick Experimental has ranked number 2 here. The Gemini 2.5 Pro is still the best one. So I was thinking if I can do some fine tuning for the Llama 4 model. But actually, I think based on their description, it requires somehow fitting in a single H100 GPU. So I think that's probably not possible for me to run that freely in a T4 GPU notebook in Colab. So instead of doing the Llama 4 fine-tuning, I think it's a great opportunity for me to learn how to fine-tune other models like the Llama 3 or Gemma 3 or other models from Hugging Face. So I think before we jump into my personal project, I want to go through some of the things like the Unsloth documentation. And why do we use this? I think it's very popular right now because it can save huge memory resources, like 70% less memory and with no degradation in accuracy. And also it can be run in the Colab notebook. It's a really awesome package for people like me running budget and want to just learn without paying things. Based on their explanation, fine-tuning a large language model basically can enhance the domain knowledge and optimize for the specific task. It actually updates the knowledge, introduces new domain-specific information, customizes behavior, adjusts model tones, personality, or response style, and it can also improve accuracy for the specific use case. Example use cases here they showed is that you can train a large language model to predict if a headline impacts a company positively or negatively. So often fine-tuning models can be used to do some traditional machine learning problems like the classification problem here. You can often use the historical customer interactions for more accurate and custom response. So often in the industries, you have domain areas like the banks, healthcare. Your customers or clients are different in their context. The conversations are definitely different. It's very interesting that, this pointed out that fine-tuning can replicate all of RAG's capabilities, but not vice versa. Like it cannot tweak the model to change the ways of doing the response. The next thing is important to know is to choose the right model and method. So basically, the low rank is introduced to fine-tune the models, the lower the number of the model weights to be updated. And the quantization low rank basically combines the LoRA with 4-bit quantization to handle very large models with minimal resources. A few parameters we can control is the max sequence length. And for the Llama 3, it supports 8 192 tokens. So yeah, I will probably use that later on. And we're going to load it in 4-bit for the quantization. The next important thing is about the data sets. So for the data sets, we usually need 2 columns, the question and the answer. And the quality and amount will largely reflect the end result. One of the important things I often come across is how big should the dataset be. So they recommend using at least 100 rows of data for fine-tuning to get reasonable results. And for the optimal performance, a data set with over 300 rows is preferable. However, the fine-tuned model depends heavily on the quality of the data set. So be sure to thoroughly clean and prepare your data. There are a few key fine-tuning hyperparameters. The learning rate. It basically defines how much the model's weights adjust per training step. The higher learning rate usually means the faster training and reduces the overfitting. The lower learning rates will be more stable training and require more epochs. And the next is the epoch, the number of times the model sees the full training data set. Usually it recommends 1 to 3 epochs. For the LoRA rank, usually it recommends a number from 4 to 128. And the LoRA alpha usually should be the low rank times 1 or the same number of the low rank or twice of the low rank. Next, I will show you my personal project like in Colab to fine-tuning the Llama 3 models with a custom CSV data. So we first set up the environment. Make sure you are on the T4 GPU resources. Once we finished, we're going to load the CSV file. So if you have watched my previous video, the goal of this small project is to basically tell the model to rewrite the AI generated prompt to be more human-like. Next, we're going to load the Llama 3 model. Here we specify the maximum sequence length to 8192 and we load in 4-bit quantization and we load the model and tokenizer from the Unsloth. The next part is the adding the LoRA adapters. So we set the rank is 16 and the LoRA alpha. So I set the same as the rank 16. Next part is to formalize Llama 3 chat template so that the model can understand the text well. It has this kind of format. It tells the model the beginning of the text and then it follows by the system instructions. But you have to specify the start header ID and end header ID and then fill in the system instructions here. Once you've finished, you put the end of token ID. Similarly for the user prompt, you put the user prompt here. And once you finish, you put the end of token ID here and also for the assistant response. So here's the system message I defined. Your task is to rewrite the AI generated prompts to make them more human-like. And the user message is the AI generated text, which is the Gemini rewrite prompts. And the assistant message will be the human written text. And then we just format it like before. So once you have defined function, you just apply it to the pandas data frame. And once you're done, we're going to create a Hugging Face data sets. Once we have the data sets, we configured the training. So we use the training arguments and a few important things, like we define the number of training epochs to 2. Here we use the trainer to wrap the model, tokenizer and train data sets, and the field we're going to use and the maximum sequence length. Then we're going to train the model. So when we train the model, we're going to monitor the GPU usage. We have 83 examples. Number of epochs is 2. Total steps is 20. The batch size is 2. The trainable parameters, which is 1.3% of the original model, which is impressive. So the training loss is showing the decreasing number. But actually, I think it's not really learning fast. Usually in this case, I think the first thing I want to do is to change the learning rate. So I want to change these numbers to basically increase the learning speed. Let me load the model again. Rerun the model, see what's going to happen. So this time you see it's definitely increasing the speed of learning, and it's going below the 2 quickly. All right, it looks good just for this small demo. After we save the model, and we can reload it here using the same function from the pre-trained and specify the saved model and the maximum length load in 4-bit quantization. And the important thing is that you have to enable this for inference. So it's basically 2 times faster. And then don't forget to apply the raw text into the Llama 3 chat format. So this time, this is the instructions and this is the new prompt. And then let's run that. I think it's doing the job right now. So, but if you look carefully, it's not changing too much of the original text. Probably it's the model is under training, and as we only have 83 examples, and yeah, that's pretty much about it. Thanks so much for watching this tutorial. I hope you found it helpful. If you enjoyed this content, don't forget to like and subscribe to support the channel. Leave a comment if you have any questions or suggestions for future videos. See you in the next one.